There's a bunch of drugs right now, promising molecules that can not only increase health span, but possibly even maximum lifespan. One of the drugs that you focus on is rapamycin. Could you discuss some of that research that you do on rapamycin and how it increases health span and lifespan?
Yeah, we got to rapamycin and the mTOR pathway because we were studying aging in simple invertebrate models like, or non-vertebrate models like yeast and worms. And what we found is that that pathway had a big conserved effect on aging, and it also was in flies. And more recently, a number of labs have shown that reducing TOR signaling extends lifespan and health span in mice. So really, it's the gold standard, I think, right now of a pathway linked to aging because it works everywhere in multiple mouse strains. And already there's beginning to be human data that using drugs to turn down TOR signaling can have positive impacts in an aging setting. So, we're excited about that pathway. Now, rapamycin is a drug that's clinically approved, and it does have side effects, but I think that there are strategies that are available that we can deliver low doses of the drug in a clinical testing setting without encountering side effects. And then on top of that, there are a number of companies, including one, Mount Tem Biopharma, that I'm involved with, but there are a number of others as well that are trying to make novel strategies to inhibit mTOR so that you could get the efficacy of rapamycin without the side effects. And probably there's a whole handful of companies taking different approaches in that regard.
Okay. Isn't there a human study not a while back that they gave low doses of rapamycin to humans?
There's a study with everolimus, which is a derivative of rapamycin.
Okay.
And what they found is that if you give people 65 and above this drug for a window of 4 to 6 weeks and then give them an influenza vaccine after that, they have a much better response to the influenza vaccine.
Nice.
And a more recent paper, which also is a more complicated strategy at inhibiting mTOR, what they found is that even a year after you stop giving the drug to people, they still have a dramatic reduction in infection rate.
Sweet.
Respiratory infections are one of the big causes of mortality in the elderly. So if you can reverse immune senescence, have the immune system work better and get less respiratory infections, that's a very positive effect on aging. So I think the signs are really good for TOR inhibition in humans as well in terms of preserving health span and even lifespan.
And there weren't that many adverse side effects in the study where they vaccinated people. But what about the second study? Were there
the same thing? But they're dosing it in a way that keeps side effects low.
Okay.
Now, the disadvantage of, obviously that's what you have to do in a healthy population. So I understand their motivation. But the potential disadvantage is if you dose that low, maybe the effect size you get is also lower. So if we can make derivatives that have better efficacy to side effects, we can dose higher and maybe get even bigger positive effects. So that's kind of how a number of companies are thinking.
Sweet. Is that what you're doing at your company, the Mount Tem company?
Yeah. Yeah, we've got derivatives of rapamycin that have different properties, and we're trying to identify the ones that inhibit mTORC1 pathway, but not the mTORC2 pathway. And we find that if you increase that differential inhibition, at least in animal models, you get a very strong efficacy and very low toxicity. So what we want to do now is to take some of these new molecules into human studies and see where that leads us.
Excellent. Do you plan on conducting any human studies in the near future?
Well, certainly we're doing that in Singapore, but we're probably not going to start with new chemical entities in Singapore because we want to work with known commodities first when we're studying healthy aging. The last thing we want to do is to take a compound and discover some unknown toxicity. It would really hurt the aging field. So we're going to start with known commodities. In the drug space, and these companies, what they're thinking largely is, let's start by trying to target specific age-related diseases that are linked to aging. And you've got more of a tolerance to do clinical trials in that space. And then we'll start collecting data on aging as well as a secondary endpoint in those studies. And if it looks good, maybe we'll transition those compounds into pure aging studies. But with new compounds that have never been in man before, I'm hesitant to put them in healthy people to start with. At
Yeah.
least, I mean, you know, in any big way.
Yeah. So how do you foresee these drugs? There's a few of them in. You brought up a list of them that there's some promising ones like not only just rapamycin but metformin and
Yeah,
NSAIDs,
yeah,
ibuprofen and
yeah,
aspirin and acarbose and then resveratrol, NAD plus
yeah,
precursors,
yeah,
factors in young blood and senolytics. I saw you bring that up in one of your talks. I think it was
yeah.
at the Undoing Aging
Yeah.
2018. And how do you foresee these drugs being prescribed to people once they have FDA approval? Would people at like
Well,
the age of 50 start taking these drugs every day?
I mean, ultimately, what I'd like to see is that maybe at 50, we